Hello guys, today we are gonna discuss about the RCC bridge. So basically RCC bridge is used for the purpose of traveling. So mainly it is used in the areas where the objections were there. That means where the like any river, something valley, etc. In that places the RCC bridge is preferred, so that the risk is less and the distance of traveling is less. Because if at all if there is no RCC bridge, it is impossible to cross the river or the valley. So RCC bridges are really important in our daily life, and we will be considering to construct it. So in this class we are gonna design and analyze the RCC bridge. So first of all, let us go for the start pro interface. Wait till the interface has been loaded. Okay, now click on new project, click on space, let it be named as RCC dam. Click on next, click on finish. Okay, here it is there. Next we will have to draw the geometry of the RCC bridge. So let us consider it as it is at the height of 8 meters at a distance of 8 meters, and so then click on cancel. Next we will be going for the adding the beams. So let us add from here to here, and then next click on exit. Next we will double click this one. So next we will be going from here to here. Okay, now it has been created, then off the grid. So in this way it will be created. So next we will be creating this view. So let us select this one, then go to translational. In Z direction the number of steps be 7 and the default spacing be the default spacing also be for 5 meters. And click on link steps, click on open base, click on OK. So in this way we will be getting the base here. So here after getting the structure we have to add mesh throughout this one, and next we have to add here the supports and the shear beams, so that these columns will not get separated. So first of all let us go and select these beams. So after selecting these beams, we'll be going for inserting nodes. Insert the nodes at the MECH point. Click on OK. It has been placed. Now go for the beam. Click on here. Then click on exit. Then go for this in this view. So here you can see this beam has been created. So we have to create same in this way. So same. Okay. Okay guys, then after this we have to add the beams here. So we have to go and add the beams here. So here we should have to add the beams here. So click on this add beam, then click on here and click on here. So here to here, here to here. So here, now here clearly you could see this. So all the beams have been done properly. So next we will be adding the mesh here, that means the plates we will be adding. So then go to add mesh or generate surface meshing, then go here to here, select point nodes, click on here, click on here, and click on here, click on quadrilateral one, click on OK, click on OK. So here you could see this, all of it has been done. Okay. So next we have to add the properties here and the beams etc. to this one. So so next we will be going for the after the geometry we will be going for the general. In general we will gonna add the properties here and supports and also loads and efficiency. For properties we will be going, and let us go for the define. Let us go for the define, and we have to define the properties. Then let us give for the first one is a rectangle which is of 0.30 and 0.30. Click on add, go to circular, click on 0.25, click on add, click on close. So next we will be going for this, and we are gonna assign this one. So let us see that if at all if any plate is present in our structure, let us select this one. So the plates have been selected, so that we have to give the plate thickness, let it be 0.25. Click on add, click on close. Okay, so we have to select the plate. So after selecting the plate we have to assign the plate thickness. Click on assign, click on yes. So it has been assigned. Next we have to assign this one. We assign the circle column. So for this only the bottom surface will be going for the circular one. So let us go for the select command, then go for the beams parallel to y-axis. So all the columns have been selected, then click on assign, click on yes. Okay. Next we will be going for the for these rectangular beams across this one. So then let's go for it, then select beams parallel to x-axis, and in the same way go for select and beams parallel to z-axis. So it has been selected, then go for the assign, and go for the yes. Okay, it has been done. So then R1, R2 and R3. So all the properties are given. Let us go for the supports. Next we can go in top view and create support. It will be fixed support. Click on add. So click on add. So select this one, then select these nodes, click on assigned. Click on yes, it has been assigned. You can see in this isometric view, supports have been given to every supporting member, that means every column. Okay, I can also see this. Next we will be going for the loads and definitions. So here the loads and definitions are present. In here the loads will be giving. So let us go for here, and if you want you can give wind, not seismic, then but I am not giving since the height is not so much. So we will be going for the load case detail. Then click on this one, and firstly the dead load will be present. It will be DL. Click on add. Next is live load. So live load, it will be double L, that means roof live. Click on add. Next is the wind, snow, fluids. So these are the only loads we should be adding. Click on close. Click on this one. So vehicle definitions we have to provide. So let the vehicle definitions be. Let it be 80 kilonewtons, and here also be 80 kilonewtons, or let it be 50 kilonewtons. So distance is, it will be 4 meters. Then click on add. Plus, click on this one. So after that, next we will be going for the live load. Dead load. We have to add the dead load. So we will be going for the dead load is the self-head, close, and live load. We will be going for the live load. We will be going for the plate loads. Let us save it and go for the plate load here. And we concentrate load, parts and pressure, trapezoidal, hydrostatic, elemental joint. So these are all the things. Then let us go for this pressure on full flat B. Let the pressure be, let the pressure be thickness, that is 0.25 into 25. So the distance we have to calculate that one. So 0.25 into 25, it is 6.25. So let it be minus 6.25. Then click on local y, it is GY in global y direction. Click on add. Click on close. Has been assigned. And we have to assign this one. Click on assign to view. Click on assign. Click on yes. Has been assigned. Next we will be going for the row live load, which is only acting on this one. So let us select all the plates. Click on this one. So all the plates have been selected. So click on assign. Click on yes. So it has been assigned here. You could see here the plate loads have been assigned. Or else we can also assign, you see here, so this will be done. Or else we can also add a roof floor load also, we could add this one. So if we go, but I am going to take the floor load on, see, plate load only. So we have to assign this. After that we have assigned. So self-head has been assigned. Then let us go for this material. Here the material provided is only concrete. Click on concrete. Click on assign to view. Click on enter. Click on yes. It has been assigned. Next we will be going for the analysis and print option. Here let us see that if at all if we get any errors or not. Click on analyze. Go to run analysis. Click on save. Let us wait. till the analysis has been completed. Here you could see that we are getting 0 errors, 0 warnings and 0 notes. Then we have to put this done, and next we will be going for the design check. In design checks we will be adding the concrete code, going to concrete, click on select parameters, select all this and go for the compressive strength of the concrete is done, and main reinforcement is done, and shear reinforcement is also done. Click on OK. Okay. Next we have to define these parameters. Let the compressive strength of the concrete be 30,000. Then click on add and go for the main reinforcement. Let it be 5 lakh. Let it be 5 lakh. Click on add. Click on sectional reinforcement. Let it be 5 lakh. Let it be 5 lakh. Click on add. Click on close. And go for these commands. Then go to design beam. We are getting the beams. Click on add. Go to designing columns. We are getting the columns here. So then click on add. And design slab or the element. And that means we are getting this element. Click on add. We have to go for the takeoff. Click on add. Then click on close. Next, we have to give this one. This one. So go to assign to view. Click on assign. Click on yes. Next, we will be going for the main reinforcement. Click on assign to view. Click on assign. Click on yes. Has been assigned. We have to go for the shear reinforcement. Click on assign to view. Click on assign. Click on yes. Has been assigned. Next, we will be going for the selecting the beams here and select the beams parallel to the axis also. We have to design the beam. We have to give the assign the design beam to the beams present in this bridge. Then we will have to go for the select option. We have to go for the next direction. We have to go for the select beams parallel to z direction. Click on assign. Click on yes. Has been assigned. Then go for the design column. Click on select beams parallel to y axis. Click on assign. Click on yes. So we will go for the design element. Design element. Then we will be selecting these elements. Then let us go for the plate cursor and click on all the plates which are present. We have to assign. It has been assigned. Next, we have to go for the analysis and print option. We have to perform the analysis and click on close. We have to analyze this one. Then go to run analysis. Let us save it. So let us wait till the design has been analyzed. So here clearly we could see that we are getting 0 errors. Then so it means our design and analysis of the structure has been completed successfully. Then go to out processing mode. Click on done. Let us select all the loads. Click on apply. Click on okay. Now this is the shear reinforcement in the dead load. Okay, in x direction. This is the shear reinforcement. That means in y direction for dead load. This is for in z direction. This is movement in x direction. This is the movement in y direction. This is the movement in z direction. So this is the beam stresses will be developing in the dead load. In case of dead load, this is the displacement. Okay. For live load, let us see here. For live load, this is shear force in x direction. This is shear force in y direction. This is shear force in z and movement in x direction, movement in y direction, movement in z direction. Okay. So you can see here. Let us go for this maximum absolute. Click on apply. Click on OK. Now here we could see this one. So here you can see here clearly. Here the stress is acting more towards the ends of this one, and this is in moderate. So this surface is safe. This is also safe. So these are all the safe, but the ends are getting stressed more. So okay. Next we will see in this animation. We'll go for the animation, go for the deflection, click on apply, click on OK. Here you will see that in live load, that means in vehicle loads, so these are the plates will be getting deflected and in dead load also these are the players will be getting reflected. Live load also same. Okay. Next we'll be going for the modeling here. In modeling we will be seeing this in a 3D rendering view. Let us wait till see here you could see this one. So this is the 3D rendering view of the rendering view of an RCC bridge. Here you could see clearly you can see this one. Okay. So these are the columns are in circular one and the beams are in rectangle shape. So here also you can see all the beams are in circular one. Here you see here. Okay. Here you can see. Here you can clearly see the design, that means the 3D rendering view of the an RCC bridge which is created. Okay, so in this way the design and analysis of the RCC bridge is carried out. Thank you guys, have a good day.